Assalamu alaikum. Dear students, today we are going to solve linear equations. Here first question is, use matrices if possible to solve the following system of linear equations. There are two techniques to solve these linear equations. First one is the matrix inversion method and second is the Cramer's rule. In first part there are two linear equations, 2x minus 2y is equal to 4 and 3x plus 2y is equal to 6. And second, 2x plus y is equal to 3 and 6x plus 5y is equal to 1. In third, 4x plus 2y is equal to 8 and 3x minus y is equal to negative 1. In fourth, 3x minus 2y is equal to negative 6, 5x minus 2y is equal to negative 10. We are going to solve these linear equations with first techniques, matrix inversion method. There are two linear equations with two variables x and y. In first step, we just write these linear equations in matrix form. First matrix having first column is the coefficient of variable x and second column is the coefficient of variable y. Into matrix having elements x and y is equal to matrix having elements 4 and 6. This matrix equation can be written as A times x is equal to b, where A is equal to matrix having elements 2, negative 2, 3 and 2, x is equal to matrix having elements x and y, and b is equal to matrix having elements 4 and 6. The above equation can be written as x is equal to A inverse times b, that is equation number 1. Here observe that x is equal to matrix having elements x and y, and b is equal to matrix having elements 4 and 6, and A inverse is unknown. In second step, we just find A inverse. A inverse is equal to adjoint of matrix A over determinant of matrix A. Determinant of matrix A is equal to determinants of elements 2, negative 2, 3 and 2, that is equal to first entry is obtained by the product of principal diagonal elements 2 times of 2 minus. Second entry is obtained by the product of other elements negative 2 times of 3, that is equal to 10. Adjoint of matrix A, that is equal to matrix having elements 2, 2, negative 3 and 2. So A inverse is equal to matrix having elements 2, 2, negative 3 and 2 over 10. First equation implies matrix having elements x, y is equal to 1 over 10 into matrix having elements 2, 2, negative 3 and 2 into matrix having elements 4 and 6. Now we find the product of these two matrices. Their product is defined as first entry is obtained by the product of first row times first column, 2 times of 4 that is equal to 8 plus 2 times of 6 that is equal to 12. Second entry is obtained by the product of second row times first column, negative 3 times of 4 that is equal to negative 12 plus 2 times of 6 that is equal to 12. So first matrix having elements x and y is equal to 1 over 10 into matrix having elements 20 and 0. These two matrices are equal, so their corresponding elements are also equal. So x is equal to 2 and y is equal to 0. In second, there are two linear equations with two variables x and y. In first step, we just write these linear equation in matrix form. This matrix equation can be written as A times X is equal to B, where A is equal to matrix having elements 2, 1, 6 and 5. X is equal to matrix having elements X and Y, and B is equal to matrix having elements 3 and 1. The above equation can be written as X is equal to A inverse times B, that is equation number 1. In second step, we just find A inverse, that is equal to adjoint of matrix A over A determinants. Determinant of matrix A, that is equal to determinant of elements 2, 1, 6 and 5, that is equal to 4. Adjoint of matrix A, that is equal to matrix having elements 5, negative 1, negative 6 and 2. So A inverse is equal to matrix having elements 5, negative 1, negative 6, 2 over 4. In step 3, equation 1 implies matrix having elements X and Y is equal to 1 over 4 into matrix having elements 5, negative 1, negative 6 and 2 into matrix having elements 3 and 1. Now we find the product of these two matrices, that is equal to first entry is obtained by the product of first row times first column. 5 times of 3, that is equal to 15, plus negative 1 times of 1, that is equal to negative 1. Second entry is obtained by the product of second row times first column. Negative 6 times of 3, that is equal to negative 18, plus 2 times of 1, that is equal to 2. 15 minus 1, that is equal to 14, negative 18 plus 2, that is equal to negative 16. Now we product of 1 over 4 into that matrix. First matrix having elements X and Y is equal to second matrix having elements 7 over 2 and negative 4. These two matrices are equal, so their corresponding elements are also equal. X is equal to 7 over 2 and Y is equal to negative 4. Dear students, solve its next part.